Hi students, today we are discussing the third unit that is nothing but structural design patterns. In third unit we will discuss the part 1 structural design patterns. In part 1 curriculum we discuss what is adaptive design pattern and bridge design pattern and one more a composite design pattern. If you need to repeat it, the key points for what is a structural design pattern, and let us see, and each design pattern have some intent, motivation, also known as something more structure, applicability, what are the some consequences, how we can implementation by using Java code, and we have to be learn a sample code, and finally what are the noun uses, which examples of related the particular pattern in the real systems, and finally what are the related patterns. Okay, we seen some code examples and what are the references of this particular design patterns. Okay, let us we see first of all what is a structural design pattern. Let us we have to be started with what is discussion of structural design patterns. Before we are discussing structural design patterns, what is the meaning of structural design patterns, what is the main motto of structural design patterns. Let us see the structural design patterns. It simplifies the structure how it simply simplifies the structure in the sense of a graphical notation of how the classes and objects, that scenario, the relationship, by identifying the relationships. Okay, what I meant to say in the sense, the structural design patterns simplifies the structure by identifying the relationships, by identifying the relationships in the sense, it is concerned with how the classes and objects are to be composed to form larger structures. Coming to the point of structural class patterns, we need to use inheritance. Which class acquires one property, so to another class properties, which have to acquire the properties from one class to another class. How to compose those interfaces or implementations, okay, in class pattern. Okay, coming to the structural class pattern, we need to use inheritance to compose interfaces or implementation. These patterns mainly focuses on how the classes inherit from each other, and how they are composed from other classes, and how they are composed from other classes. The if we have to be taken as a simple example, ma'am, let us we consider how multiple inheritance mixes two or more classes into one class. Okay, so the result is a class that combines the properties of its parent classes. So this structural design pattern particularly we are making use independently, developed by the class libraries, so we are working together. Another more example we have be taken, if we have to take a class form of the adapter pattern. In generally, an adapter makes one interface, that is nothing but the adaptee. It conforms to another interface, it converts to another interface, thereby it providing a uniform abstraction, thereby it providing a uniform abstraction of different interfaces. Okay, user interface, coming to the design pattern subject related to, it is a reusable or recurring component which designers used to solve some common problems, in user interface design. Okay, we need to coming to the interface point of view, in Java it is so related, we need to achieve abstraction. There can be only, we need to study abstract methods and variables. Yes, abstract method is a method that contains only that contains only a method how we can declare, not method body you are implemented in the code itself. So we need to achieve abstraction and multiple inheritance in this concept. Okay, that means what I meant to say in the sense here, as a simple example, we need to how a multiple inheritance mixes two or more classes into one class. So the result of a class that combines the properties of its parent class. So this structural design pattern may follow, particularly we are making use independent developed class libraries work together. Okay, here one more example if you take, that is nothing but adapter pattern. Adapter pattern, what the main motto of adapter pattern? It adapts an interface to an expected interface. Okay, to adapt an interface to an expected interface. Okay, in coming to the structural design patterns, we need to study about 7 design patterns. Okay, first one is adaptive, and second one is a bridge, third one is a composite, and fourth one is a decorative, fifth one is a facade, sixth one is a flyweight, and finally we need to study the last design pattern, that is nothing but a proxy. Okay, this is the brief discussion of a structural design pattern. It simply, the structural design pattern simplifies the structure by identifying the relationships. So these patterns mainly focuses on how the classes in how the classes and objects are composed to form larger structures. Okay, we need to take somehow the class inherit from each other and how they are composed from other classes. Okay, it is the main motto, main intent of a structural design pattern. Coming to the part 1, a structural design pattern, the first design pattern we need to study, that is nothing but adapter. Okay, the name says adapter. What the adapter? To adapt an interface to an expected interface. Okay, now we need to study the adapter, a main agenda here. What is the main intent? And intent in the sense a short statement that tells us what the pattern do. Okay, and coming to the motivation, what is the main motto of this adaptive design pattern? And coming to the structure, how the structure identifying the relationships, how the classes and objects are composed to form, to make a larger structures. And coming to the applicability in the sense which design pattern, where it is used, in which design situations we are used. And coming to the consequences, how it describes its result of whatever we are applying of this particular pattern. And coming to the noun uses, in the sense, if you've seen some, what are the examples of this pattern in the real systems. Okay, and coming to the related patterns, related means these patterns are related to some other patterns that is very similar to that pattern. It is very relevant, or we can say it is very similar to that. And finally we discuss what is the reference of this particular pattern. Okay, and now see, today we are, let us start the first design pattern under coming the concept of a structural design pattern, that is nothing but adapter. What adapter? It comes under a structural design pattern amma. What the main intent in the sense, if you need to change the interface of a class into another interface of a class which is expected by the client, what the meaning in the sense, let us take some real-time examples. If you take some USB-C port, if you need to be connected with USB pen drive, it is nothing but adapter pattern. It works as a bridge between two incompatible interfaces. What I meant to say here, for example, if you have to take one more real-time real life example, always all are preferable phones. Okay, in a socket we place a adapter, and adapter will convert from one interface to another interface. Okay, expected to a client. For example, if you take if you need to take a phone adapter, my example, real life example, phone adapter. It will phone adapter takes 220 volts, but the phone will takes only approximately 9 volts or 10 volts. Adapter pattern, it works as a bridge between two incompatible interfaces, in the sense two incompatible, not matchable, incompatible, compatible in the sense matchable, incompatible. Okay, the adaptive design pattern allows what it allows, it allows two incompatible classes how to interact with each other, incompatible classes to interact with each other, how to convert the interface of one class into another interface of another class, whatever expected to the client needs. So adapter lets classes works together that could not otherwise because of incompatible interfaces. Okay, what does the main motto? The adaptive design pattern allows two incompatible classes to interact with each other. Okay, so we need to convert the interface of a class into another interface which is expected by the client, in the sense another interface whatever the client expected. Okay, so let's adapter classes works together that could not otherwise because of incompatible interfaces. Okay, if you need to take some real time example, pen drive, USB-C, USB, okay, how the media access control, how to control the pen drive, USB-C, how to access there. And coming to one more real life example, that is nothing but a memory card reader. In the sense, if you need to insert the memory card chip into a laptop, okay, in the sense insert, if you have to reader, it means the adapter. If you need to insert adapter, okay, that is nothing but reader. If you need to insert the chip laptop, whatever the memory will be accessed there, it will be a convert from one interface of a class to another interface a client's expected. Okay, and one more example, phone adapter, already I say to you. And coming to the technical real life coming to the subject point of view, technical real time example, I can tell to you, if you need to take some Java application in database, Java application, if you need to say it, if you need to create some Java application, the adapter will by connected the Oracle Java JDBC or driver and MySQL JDBC driver and system based JDBC driver. It will adapt the Java application, and the database will be converted in the convert from one interface of a class to another interface, whatever the clients expect, Oracle or MySQL database or system database, whatever it may be. Here the main intent of this pattern, the adaptive design pattern allows two incompatible classes to interact with each other, to convert the interface of a class to another interface, whatever the clients expects. Okay, so the adaptive design pattern works as a bridge between two incompatible interfaces. That is the main intent. What does the pattern do there? Okay, and coming to also known as one more name, we can call it as a wrapper. A wrapper. And coming to the motivation section, motivation, what does the main motto of this adaptive design pattern, in the sense, let us consider sometimes, listen carefully ma'am, sometimes a toolkit class that's designed for reuse purpose is not reusable only ma'am, because its interface does not match the domain, whatever the domain specific interface and application it requires. Okay, what is the meaning of the interface? An interface, we need to achieve some abstraction, and there can be only some abstract methods and variables. It is used to achieve mainly abstraction and multiple inheritance. So we are reusable or recurring some components which designers use to solve common problems in user interface design. Consider, for example, I will take some drawing editor that lets users, I'm a user draw and arrange the graphical elements like lines, a point, square, a circle, etc. If you need to take into pictures and diagrams. So here the drawing editor, a key abstraction, what ma the drawing editors key abstraction is the graphical object. Okay, is the graphical object which has an editable shape, line, and can draw itself. So the interface, okay, for graphical objects is defined by an abstract class called shape. Okay ma, here I will give some class name shape. Na here some set of operations we have to be written there: set location, get location, undisplay function, display function, fill function, set color. Here the interface for graphical objects is defined by an abstract class. What is an abstract class? Abstract class is a class that contains what it contains, for all the implementation of some methods and variables, some abstract methods if you need to implement it but not implemented in the code. Okay, that is the main. We need to achieve some multiple inheritance and abstraction. Coming to the point of interface, the user interface for graphical objects is defined by an abstract class called shape. Here look at this picture representation of motivation. The editor defines a subclass of shape for each kind of graphical objects. A line shape class for lines, a polygon shape class for polygons, and so on, whatever it may be, square, point, circle, whatever the client expected. Okay, here we see the relationship between one-to-one relationship between x to xx circle ma. Here listen carefully what I meant to say, in the sense the classes for elementary geometric shapes like line shapes and polygon shapes are rather easy to implement because their drawing and editing capabilities are limited so but a text shape is there na subclass. Yes, shape, or if you have some but a text shape subclass that can display and edit text, whatever if you need to implement, since even basic text editing involve a complicated screen updates and buffer management here. So how can you existing and unrelated classes like text view, this text view work in an application that whatever the classes expected to you, so that it will conforms the shape interface. We could change the text view classes so that it conforms to the shape interface, but that is not option unless we have to the toolkit, a source code, whatever the source code we need. It could make sense to change some text view. The toolkit should not have to adopt a domain specific interfaces just to make one application work. Okay, this is the main motivation of the text shape. So what the text shape, it adapts the text view interface to shapes. Whatever we can do this in one of two ways. The first one is by inheriting shapes. You look at this diagram, by inheriting a shapes interface and a text views implementation, or we can say the second point by composing a text view instance within a text shape, and we are implementing a text shape in terms of a text view interface. So these two approaches corresponding to the class and object versions of the adapter pattern. So the text shape is called an adapter here. Okay, the diagram what here illustrates to you, in the sense the diagram illustrates here the object adapter case. It shows how the request in class shape, how the request declared in class shape or converted to a get extent request defined the text view during the text shape adapts some text view to the shape interface like point, points, lines, squares, circles. Okay, so the drawing editor can reuse the otherwise incompatible text view classes. So we are oftenly the adapter is responsible for the functionality whatever we need to adapt at the class does not provide here. So how the diagram shows here, an adapter can fulfill such responsibilities. So the user should be able to drag every shape of object to a new location interactively, but the text view is not designed here. So the text shape can add this missing functionality by implementing shapes. We want to be we want to be create some set, create some locations, some filling some set colors, like we have to be create some operations which returns an instance of the appropriate subclasses ma. So here these are the these diagram illustrates how the object adapter case, how it relates. Okay, and coming to the structure related to the class, here you have to be look at this. This is nothing but a class adapter ma. Adapter works as a bridge between two incompatible interfaces. Here the structure representation, how a graphical notation of classes and objects, how they interrelate and how they represent a scenario like this ma. Look at this, a class adapter uses a multiple inheritance, more than one multiple inheritance to adapt one interface to another. Like we have to be look at this, a client, a target and request some operation, and adaptee specific request, domain specific request of some function. We have to take here a class adapter here uses multiple inheritance to adapt one interface to another. Okay, adapter request function, we can say as access specifiers private or protected. We need to return some specific request, we need to return a specific request. This is the class structure ma. And coming to the object structure, what the object structure here relies, it relies on object composition. Here look at this, client, target, request, the relationship to client to target, and it inherits the adapter request function. And adaptee in the sense it relies, an object adapter relies on object composition. What it adaptee here, adaptee, we need to specify the domain specific request, we need to return some adaptee a specific request a function. This is nothing but object structure. And coming to the applicability, what ma applicability in the sense, what are the main uses of adapter design pattern. Use the adapter pattern when, in the sense when you want to use an existing class and its interfaces, it doesn't match the one you need. In the sense, if you to use an existing class whose interfaces does not match the certain requirements, so and its interface does not match the one you need, whatever you need. Okay, and coming to the second point, if you want to create a reusable class, that cooperates with unrelated or unrelated classes, that is classes that don't necessarily have compatible interfaces, that classes don't have necessarily a compatible interfaces. We need to create a reusable class if you thought that the interface are not necessary compatible with callers. Okay, that is the main applicability here. If you need to create a reusable class that cooperates with unrelated classes, that classes don't have necessarily a compatible interfaces. And coming to the third applicability of adaptive design pattern, If you want to use here, listen carefully. If you want to use several existing subclasses, but it is impractical to a subclass everyone, if you take some object adapter only, in the sense, if you need to take some object adapter only, in the sense, if you need to use several existing subclasses, but it's impractical to adapt their interface, by subclassing everyone. So an object adapter can adapt the interface of its parent class. Listen carefully. An object adapter can adapt the interface of its parent class. Okay. And now we seen what is the class adapter pattern, pros and cons of adaptive design pattern. Coming to the class adaptive design pattern, pros and cons, in the sense advantages and disadvantages. Yes, exactly. Now coming to the pros of adaptive design pattern, if you need to take only one new object and no additional indirection, and we need to take some less code it required than the object adapter, and it can override adaptive behavior as if you need required. And coming to the disadvantages of adaptive design pattern, it requires subclassing. It is very tough for single inheritance, ma'am. It is very tough for single inheritance. It requires subclassing, and it is very less flexible than object adapter. And coming to the object, in previously we seen class adapter pattern, what are the pros and cons. Now we need to study object adapter pattern, what are the pros and cons of adapter design pattern. It is more flexible than class adapter. Okay, it doesn't require a subclassing to work. It don't require what the task will be do in subclassing. And coming to the one more point of advantage of adapter design pattern, it is related to the object. Adapter works with adaptee. Yes, exactly. Adapter works with adaptee and all of its subclasses. Yes, and all of its subclasses. Coming to the cons. Cons, in the sense, what are the disadvantages of adapter design pattern? It is related to the object section. It is very harder to override adaptive behavior. Yes, so if you need to override adaptive behavior, it requires more code. Whatever you need to implement properly, it requires a more code if you need to implement properly. Okay, if you need to study the implementation in further video. Okay ma, up to now, thank you.